Hi everybody, welcome to another video in Math 1324, section 8.3, conditional probability, intersection and independent. So this section we study about conditional probability. So probability of A given B have already occurred. So B is already occurred. Now A happening. It's denoted probability of A slash B. So B already occurred and now probability of A. So suppose that there are two. So the formula for that is the probability of both of them over probability of B. Right. So and look at an example. Suppose that there are two majors in particular college, nursing and engineering. The number of students enrolled in each program is given. So that's what we have. If a student is selected at random, find the probability of nursing. So if one student is selected at random, probability of nursing, we just count how many we have in nursing over how many we have in the sample space of 150. Nursing total is 100 of sample space, that's 150. So we have that cancel 50 top and bottom, we have 2 over 3. Of course we can just divide them. And convert to fraction, to thirds. Probability of graduate student, so number of grad student over the number of sample space. Grad student we have total of 60 over 150 divided by 30 on top and bottom. We have 2 over 5. If we convert to fraction, that's 2 over 5 or 0.4. Next, 5 probability, that is nursing and grad student. So we just count how many we have nursing and grad student over number in the sample space. So nursing and grad student, they're 47 out of 150. 47 over 150, I think it is already reduced. Yeah, so just that, always said 0.3133. Right. Just count. Next, given that an undergraduate student is selected, what is the probability that the student is nursing major? So that is, find the probability of nursing and undergrad. So that means we just count how many we have in undergrad. So we say that is nursing undergrad. So even that we have to have an undergrad. How many of them is nursing? So we have to have nursing and undergrad. So nursing and undergrad. So undergrad is this. There's 90 in total. And then nursing out of those is 53. So we have 53 over 90. Sorry. They're total of 90. And there are 53 of them, that's nursing, so 53 over 90. Again, I think that is reduced already. Now if we want to, we can use the probability, but again, instead of use p, we can also use n, because if we write like this, I'll just prove quickly here. You can try as n, a, b, n of s, then n of b over n of s. Divide fraction is multiply reciprocal. And then we flip. That cancel out. So either we use p or we use n. In this case, I just use n. Right. Now the probability of graduate given engineering. So we're just going to say it. We divide by how many we have in engineering. And then we have for both grad and engineering. Grad and engineering is 13 over all of the engineering of 50. Right. There are 50 engineering total. Out of those, there are 13 graduate students. 13 divided by 50, we can reduce this. No, we not reduce, but we can divide it. So 26 or 26%. Right. So we just again count. So use in this case, we're not going to divide by number of sample space. We divide by the number of particular event, and this is going to be a number of both. That's it. Right. So now not on the form of conditional probability is this kind of a sample, which is very not as difficult to understand. Right. Let's see. An IGS contains 4 cans of apple juice, 8 cans of grape juice, 6 cans of orange juice, and 5 cans of pineapple juice. Suppose that you reach in the container and randomly select 3 intersections. Find the probability that all of them are grape juice. Right. So remember the problem where we do the different stage. So in this case, we just write the first one is grape. The second one have to be grape. And then the third one is also grape. Now let's just count how many we have total. 4 plus 8 plus 6 plus 5. That's 23. 23 total cans. Now there's 4 grape juice. So if the first one is grape juice, it have to be only 4 out of 23. Now to take that and put that away, now there's only 22 left, and out of those only 3 grape left, and put those 2 away, there are only 21 left, and out of those 2 of them are grapes. So multiply straight across. 4 times 3 times 2 over 23, 22, and 21. So 4 times 3 times 2 divided by 23, 22, and 21. So we have that. If we convert this to fraction, that's 4 over 1771. Right. Next, I'll find the probability of selecting no grape juice. Okay. So that means the first one is not graph, and the second one is also not graph, and the last one is also. Right. Now there are 23 in total, right? If there are 4 graph used, that means 23 minus 4 have to be 19 that are not graph. Now put that away, there are 22 left, and there's still 4 of them are graphs. So 22 minus 4 is 18. And put those 2 away, there are 21 left, and there's 17 that are not graph. Again, multiply 3 across. Over 23, 22, 21. So 19, 18, 17 divided by 23, 22 times, and times 21. And with that, we convert to fraction. 969 over 171, or 0.547. Now, so this is the probability of, let's just write 3 graphs, probability of 0 graph. Find the probability of at least 1. And we did do a similar problem like this on the previous section when we said at least 1 is the complement. Complement of at least 1 is none, right? At least 1 meaning greater than or equal to 1. Complement of this complement of at least 1 greater than 1 is less than 1. And of course less than 1 meaning none. So we say probability of getting at least 1 graph is equal to 1 minus probability of getting no graph, which we already did. 969 over 1771. Alright, so we have AO2 over 1771, which is 0.453. Right, so again, complement, probability of complement event. Next we have 2 cards are drawn without replacement. So pick the card, keep it from a standard 52 card deck. Find the probability that 2 clubs are drawn in succession. Again, the club is like this or like this. So find the probability that we have the first one is club and the second one is also a club. So the first club and the second one is also a club. And there are 13 clubs out of 52. After we select that, there's 51 left, and there are 12 left that are clubs. So again, multiply straight across. We have 13 times 12 times 52 over 51. divide 52 times 51. So that gives us 1/17, or 0.0588. Right? Yeah. So that is, it's called conditional probability because whatever we select on the first one affect whatever we select on the second one. So given that the first one is something, what is the probability of the second one is something else? So that's what it is. Right, now we have a little game. Suppose there are 4 cards of the same suit, 4 cards with 4 suits. So we have 1, 2, 3, and 4. Right. For this one, I need to zoom in, zoom out. Right, just say there's a game. We have 4 cards like this, and now I'm just scramble. And if we select 2 cards, if the cards have the same color, you will win. If you select the cards that are different color, I will win. So let's say 4 cards like this. If I select 2, and if they have different color like this, I will win. Let's do this again. Just scramble. And again, let's pick this 2. Again, different color. So I will win again. Now just keep scrambling. Right, now let's pick this 2. Okay, this time you win. So you win 1 out 3 times. In the long run, it's not going to be the case. Right, so let's look at that. Alright, so it says that you will win if you have the same color, you lose if you have different color. So let's just say, I just write out all of the probability, all of chances. So let's say the first card could be a red card or a black card. And after that you can have a red card or a black card. Red or black. So in that case we have different scenarios. We have red, red, red and black, black and red, and black and black. Now, getting a red card, there are 2 out of 4, that's easy. Getting a red card again, now you only have 3 cards left, and out of those there's only 1 red card remain, right? Originally you have 2, but you pick that red card, then only 1 left. So red and red is this. So multiply straight across, you have 2 over 12 reduced by 2, which is 1 over 6. Now red and black. The first one is red, there are 2 over 4. But then there are 3 cards left, and there are 2 red cards originally. You pick 1. That means only 1 red card left, and then 2 blacks. So that's what we have. And multiply, we have 4 over 12. Which reduce, you have 1 over 3. Now, black card, there are 2 over 4, and after you pick that out, there are 2 red cards left out of 3, and that gives us 4 over 12, right? So if there's 4 cards like this, pick out the first black card, there are 2 red left out of 3. And black card 2 out of 4, and if you pick that out, there are 3 left, so 1 out over 3. So that gives us 2 over 12, so 1 over 6. Now the chance for you to win is when you have the same color, right? Same color here, so that 1/6 and 1/6. So probability of winning is 1/6 plus 1/6, which is only 2 over 6, which is 1/3. And this to a probability of winning 1/3 plus 1/3 will be 2 over 3. Of course, you have a lot more chance of winning than losing. Right. What next? I just want to introduce the concept of dependent. What we have, example 3 or 4 here are dependent events, because whatever we select on the first step affecting whatever we have on the second step. And the definition for the dependent event is that 2 events are dependent when the outcome one event affects the outcome of the other. If they're independent, of course, they're not dependent on each other. And if they're independent, we can just multiply like this. Like I said, I just want to introduce the concept of dependent event, independent event. But the majority here have to be able to do the problem that have to do with conditional probability. And with that, we finish section 8.3. As always, thank you for watching, and see you in another video in Math 1324.